Okay, hello guys, hello friend. My name is Patrick Isama Elang. I've been working in networking for more than 10 years. Actually, I've already graduated with my training at Polytechnic in Yaoundé. So I want to share with you my knowledge and if you are students or you are preparing the CCNP lab anchor. So this area is your area. If you also you are also an IT networking or an IT developer, this area is also your place. So without losing time, let's begin. If you have any question, queries, you can just put your comment below and then I'll try my best to give explanation. So the title of the lab is use the Netmiko Python module to configure a router. Okay. Um, so this is the we are going to use the PC with the CCNP VM and the router. This one is optional. Okay, objectives. Build the network and verify connectivity. Import Netmiko Python module. Use Netmiko to connect to the SSH service. Use Netmiko to send verification commands. Use Netmiko to send and verify configuration. Use Netmiko to send an erroneous command. Um, Modify the program used in this lab. Background. With the evolution of the Python language, the Netmiko Python module was emerged as an open source project hosted and maintained on GitHub. In this lab activity, you'll use Netmiko in a Python script to configure and verify a router. Required resources: one router, one switch, one PC, Ethernet cables as shown. Part 1 Instruction: build the network and verify connectivity. In part 1, you will cable the devices, start the CCNP VM, and configure R1 for access over an SSH connection. You'll then verify connectivity between the SSH, the CCNP VM, and R1, as well as test an SSH connection to R1. Step 1. Cable the network as shown in the topology. Connect the devices as shown in the topology diagram. Part 2. Start the CCNP VM. So let me start the CCNP VM. Okay, this is my CCNP VM. Let me start it. So the CCNP VM is located inside my Oracle VM virtual box. So let me start it. It will take some time. Okay, so here we are. So this is the CCNPVM areas that we are going to use. Okay, so if you have not completed a lab, install the CCNP virtual machine, do so now before continuing with this lab. So I've already completed this lab, so actually I don't have problems with open VirtualBox and start CCNP virtual machine. It's done. Enter the password student pass to access the Ubuntu desktop. It's done. Okay. Next, um, I'll do one thing. Okay, I'll bring this one here. This one I should ignore this one before actually, and then this one. Okay, so enter now step 3, configure R1. This is my R1. Console into R1 and apply the following configuration to configure basic settings and enable netconf, resconf, and SSH. Mm, how to enable netconf. Actually, it's conf terminal. Mhm. Mm, Yarn netconf netconf, yeah, enter. Okay, so to check it, you should enter show platform software yarn process, enter. Okay, running. So this is actually how to if you want to enable netconf, this is how you can do that. First of all, you enter this command netconf yarn, okay, and then this command show platform software yarn management process. Okay, this is the command. Running means that everything is okay. Rest enter. Okay, actually also restconf has been enabled. As you can see here, restconf start. So actually netconf works fine, restconf works fine as well. So everything is okay with netconf, and also SSH runs as well. It's okay. So do that. What I'll do, I'll copy this one to configure R1. I'll copy this one. I'll copy this, and then I'll come here. I'll paste it. Paste. Then I'll modify because we don't have the same IP address. So actually, this let me show something. Let me check something. Show IP interface brief. Actually, show IP interface brief. Enter. So there is no IP here. Um, I will do modify this one, and then I'll put my gigs 001. Sorry, one should be 6109. No shirt. Okay, this one is 66565. Okay, here is 65. This one actually 65. Okay, because actually it's the IP address that I'm going to use 16 sorry 65 192.168.56.0. 56.0. This is the IP address. This is the network that I'm going to use. Okay, so let me copy this one. Sorry, let me change the password as well. The password is Cisco. The username is Cisco. The password is Cisco. So let me copy this one. Copy, and then let me paste it. Let me paste. Let me paste this one. Okay. Show IP interface brief. Enter. Everything is up actually. It works. Okay. So step 4, verify the CCN PVM can ping the default gateway. In the CCN PVM, open the terminal. So it's already done. This is the terminal. It's already open. Verify that CCN PVM is connecting to R1 in a terminal window by either entering IP address to verify the CCN PVM receive IP addressing from this DHCP server, or simply by pinging R1 at this IP address 192.168.1.1. Enter Ctrl C to break out of the ping as shown in the example output below. Okay, so let me do that. First of all, let me check the IP address of the CCN PVM. So actually is 192.168.56.102. This one here is 109. So let me see if I can ping I can ping this one 192.168.60. Okay, as you can see, it's pinging. It's pinging. Pings work. Okay, as you can see here. Let me break it. Control C, and here let me try to see if the ping works as well. As you can see, it's pinging. As you can see, it's pinging. Okay. So ping, everything works. If the CCNP has not received IP address, IPv4 addressing, check your physical connections between the host PC and R1. Also verify that R1 is configured correctly according to the previous step. Establish an SSH connection to R1. Step 4, open a PuTTY SSH client. So let me open PuTTY here. PuTTY, it's okay. Then enter the IPv4 address for the default gateway. So this is the IP address that has been created. For my case is this one. Click open. You'll see the effect here. Open. So the username is Cisco and the password is Cisco. Enter. It's okay. It's good. You see here. You see here. Logging successfully. R1 here is opening. Everything works fine. Okay. It's okay. You should be able to log to R1. This is my case. I'm able to log in to R1, as you can see here. Okay, with the username Cisco and password Cisco123. This one, but in my case, is Cisco. If not, verify your SSH configuration is correct on R1. So for my case, it works. Let me terminate. You'll see that it will log out here directly. Let me terminate the SSH. You can see here, user Cisco has exited TTH session. It's closed. That's why you have this message. Okay, very good. Import Netmiko Python module. In part 2, you will install the Netmiko module into your Python environment. Netmiko uses the SSH connection to access network devices. It has built-in functionality to execute verification commands and apply new commands to the running configuration. Explore the Netmiko module on the project GitHub repository. This is the address. Okay, in the CCNPVM, start idle and verify that Netmiko is installed by importing it as shown. Okay, so let me open idle. This is idle here. Let me open it, this one, and this one. Okay, as you can see, Python, all these things, all Python. Okay, let me write import netmiko, enter. Okay, that's good. Part 3, use Netmiko to connect to the SSH service. In part 3, you will use Netmiko to connect to the SSH service running on R1. Create a new script file. File, let's do that. File, new file. Save the file as Netmiko script. This one. Let me save it. Save it as Netmiko script.py. Save. Okay, that's good. Okay, create a variable with the SSH attributes. The Netmiko module includes the connect handle function. This function requires the following parameters to establishing an SSH connection with the iOS XE device. Device type, identify the remote device type, host, the address, host or IP of the remote device, port, the remote port of the SSH device, username, remote SSH username, password, remote SSH password. In your netmiko script.py, import netmiko's connect handling function from netmiko import this one. So I'll do one thing. I've already copied all these commands, okay, to go fast. I've already copied this. It's the best way to go fast. I've already copied. Let me open it. I will just copy and paste. This is the area. This is the I've already copied it here, as you can see. Okay, so we are not going to lose time by doing all those things. We are just going to copy and paste. It will run the same like here. So from this one, so let me copy this, copy, come here, paste, enter. Okay, enter the following information from the connect handle function. So this one from here to here. Let me copy this, copy and paste. So I'll change the IP address. For my case is let me check show IP interface brief. For my case is this one. This is my IP address that I'm gonna put here. Dot okay, and the password, remember, is it was 6K. Siska. Okay. Okay, save the script and run it. Let me save it. Save and run it. Let me run it. Actually, let me run it. Run. Okay, as you can see, it's good. Here, you see success here with inside the router. You see, I got this message logging success Cisco. It's okay. And here, everything is okay. Restart is the same here. There is no error. Okay. Save the script and run it. You'll see the following output if your script did not have an error. There's no error, so this is the output. It's okay. Part 4, use Netmiko to send a verification command. In part 4, you'll use your Python script to send verification commands to router R1. Step 1, use the Netmiko function send command to send a command through the SSH session. Set a variable to hold the output of the show command you are sending. Use the send command function of the SSH client object, which is the SSH session previously established, to send the desired command. In this case, we are sending show IP interface brief. Notice that the command does not have to be the full command. It can be any command that the iOS client will accept. So it's command line. Okay, iOS command line will accept. Output this one. So let me copy. As I told you, let me output this one. So this, copy this, copy, and then I'll paste here. Copy and paste. Okay. Save. Don't forget to save and run it. Run it. Run. Okay. As you can see here, it's okay. You can see here. You can see this one logging success directly. As soon as you make configuration here inside into the system BVM, it will automatically brings messages here inside the router. As you can see, it's okay. There is no error. Okay, run the program. You will see the following output. This is the output here. This one. Netmiko script. This one. Py. Netmiko script py. Everything is okay. Okay, next step 2. Print and format the content of the output variable. The return content from the function is stored in the output variable. In the interactive interpreter, enter output to see the content of the variable as shown in the following. Okay, so let's do that. So let's write here output to see the content. Output, enter. As you can see here, you see the content. So this one is the IP address of the router. This one, you see here, this one, everything works fine. It's good. As you can see here, everything is good. Same here. Okay, output next. B, the content of the output variable can be made readable with the format option of the print brackets command. Also, this characters is used here to add a blank line after the output is printed. Print this one. Let's copy it. and paste as well. Print, copy. What's happened? Copy, copy, and then come here and paste. Okay, save and run it. Save and run it. Run. Run your program now. Run. Okay, as you can see here, you see logging success. Okay, as you can see, everything works. You see here now, this one. This one is the IP address of my router, as you can see here. With this command, this is the effect. This is the effect of that command here. So it works fine, and the logging is success. Okay, so part 5. Let me first retake this one as well. Okay, part 5. Use Netmiko to send and verify a configuration. In part 5, you will send configuration commands to create a new loopback interface on R1, and then verify that the interface was created. Step 1. Create and send a list of configuration commands to R1. Add the following config commands list variable to your netmiko script.py. If multiple students are accessing R1 at the same time, use the loopback assigned to you by your instructor. Otherwise, you can use loopback1 as shown below. Note, replace student's name with your name, leave the backslash in the description command. The backslash escapes the apostrophe so that Python does not read it as a closing quotes but as an apostrophe. So this one, let me copy it as well. Let me take it here. Let me copy it as well. Config command. So here we are. This one. Let me copy this and let me come here. Let me paste that one. Copy paste. Okay. Okay. Let me change. So let me put another name. Let me put Jeremy, for example, Jeremy here. Okay. Okay. Create a new variable called send_config to hold the results. Then use the send_config set function of the SSH command line object to send the commands to R1. So this one as well. Send this here. Let me copy this. I'm gonna copy. Oh, I'm gonna copy this one and then comes here and paste. Okay. Print and format the content of the send_config variable. Use the print function to format and display what is stored in send_config. Then resend the send command function and repeat the print function for the output variable so that you can see uh, the new loopback interface in the show IP interface brief. Okay. So let me do that. Use the print. Let me copy all this guy, all this one, uh, the tree. 1, 2, 3. Let me copy this. Copy, copy this one, and then come here and paste. Okay, 1, 2, 3, 1, 2, 3. Okay, save. Let me save it. Save and run your program. You should get output similar to the following. Okay. This is the, let me run it. Run. Oh, there is a mistakes. There is an error. Invalid syntax. What's happening here? Okay, let me check. As you can see, this is the mistakes. Okay. Oh, this one should go down instead of remaining. Okay, let me fix that here. This one should go up here. Oh no. Wait. I'll do that again. I'll look back. So this character here. Wait. I'll do this print. I'll copy it again. This one I'm gonna copy here. I'm gonna paste it here. Okay. Now this one I'll copy all this. Okay. I'm gonna copy here and then I'm gonna paste here. Change here. I've said this one I'll put Jeremy. Okay. Save. I think it's okay now. Let me check it first. This one, description, this one, IP, send, this one, print. It looks good. Okay, let me save and run it. Let me run it. Run. As you can see, it's okay now. Here. You see how it works? Very, very good. You see the content? It works fine. And you see here, sorry, here. You see here, configure, everything is enter. You see those new messages coming from here, coming from here, here. And if you enter show IP interface brief, you will see that this loopback has been added. It was not there previously. As you can see here, it was not there. With Python, you can add directly from your messages to the routers. As you can see, it was not there previously. You see, show IP interface brief empty. And when that IP address of this 192.168.56.109, it was alone. This one, you see, it was alone here. But actually, you see, this one was added. This one, 10.1.1. Why? Because of this configuration here. And you see the content. So everything works fine. Everything works good, actually. So let's go ahead. You see, it's the same here. Same. It's the same. It's the same. The same. Conf term. You see, conf term. Everything is the same. Conf. This is the new loopback here. This is the new loopback description. Students. Jeremiah, as I said. Okay. Everything works. It's okay. Yes, it's up. Okay. So next, part 6. Use Netmiko to send an erroneous command. Netmiko works similarly to copying and pasting a configuration script into the router command line. Therefore, like when you paste a script in, Netmiko will execute every command that it can. If a command fails, it will continue with the next command. Other automation tools typically will not apply any configuration changes. If one or more commands are rejected, in part 6, you'll use Netmiko to configure a new loopback address with a duplicate IPv4 address. Step 1, create a new loopback interface with the same IP address. Copy the config commands variable to the bottom of your netmiko script.py script and modify it to store a new loopback interface that used the same IPv4 address as the previous loopback interface. If multiple students are accessing R1 at the same time, add 1 to the number of the loopback assigned to you by your instructor. Otherwise, you can use loopback 2 as shown below. Okay, so as I said, as I did previously, let me copy uh, that one and paste it. So this is the output here. Copy, copy comes here, and then paste, paste. Okay, let me put the name of um, Michael. Michael. Okay, let me save it. Don't forget to save it. Okay. Look back to everything works fine. Send the commands and print the output like you did for the first look back interface. Okay, this one. So let me copy it once again. I'll copy here. I'm gonna copy here. Sorry, I'm gonna copy here. Sorry, I'm gonna copy this one. Copy, and then I'll come here, paste, paste, uh, save. Okay. Um, I'm gonna copy and save this one. Okay, let me check something. I took save and run. Okay, save and run. Here we are. Save and run your program. You should get output similar to the output below. Uh, Notice that the new loopback interface was configured. However, it is not active because IPv4. So what we are going to do is that we are going to put the same IP address of loopback here, okay, to see this error messages, to see this error message, sorry. Okay, so we are going to put, instead of 2.1, we are going to put the same IP, 1, 1 as well, to see the overlaps, okay. Save, and then let me take this one as well. Wow, sorry, this one. Okay, so this is the IP address. This is the same IP address with the different number of loopback. You will see the error message. So let me save and run it. Run. As you can see here, you see here overlaps with the look back one. You see this overlaps, like in the topology, overlaps, same. As you can see, why? It's just because it is the same IP address. Okay, it's not complicated. Same IP address, you see this overlaps here. And as you can see here also, yeah, you see these messages, these log messages, look back to change. See? So you see this overlaps. Why? Because the same IP address. Okay, same IP, save and run. You should get output similar to the output below. Notice that the new loopback was configured, however, it's not active because, so if you try to make show IP interface brief, as you can see, it's not active. Loopback 2 uh, is there, but it's not assigned. Why? Because of the same IP address. So it's not active because of this overlap. Okay, so uh, on assign here, and you have the same message here. Here, sorry, here. Uh, where is this guy actually? Oh, where is this? Sorry, you have the same here. Actually, I'm running a lot of, so as you can see here, you see on assign here, on assign here, same, because as I told you, the same IP address. So you see this overlaps here, so it works. Next, so modify the program used in this lab. The following is the complete program used in this lab. Practice your Python skills by modify the program to send different verification and configuration commands. Okay, this one, this one, this one. So what you are going to do, actually, you are going to change. Instead of this overlaps, we are going to fix that. So we are going to put here um, 2, 2, 1. Okay, and this here we are to fix it. You'll see that it will add it automatically there. Save and let me run it to see the effect here. Uh, that overlaps will disappear. Okay, as you can see here, now you have this one, everything good, looks good. This one is not unassigned like previous, like before. Actually, it works fine. Let's go inside this router to see that it's come up. Show IP interface brief. As you can see now, it's up. Before it was not assigned because of that overlaps, but actually it's okay. So what you can do is to add the, because the lapse, I think the lapse is over. Okay, it's over. But what you can do, the exercise that you can do is to add 2 more loopbacks to see the effect inside the router. So we'll do that. So I'll give you 1 minute for you guys to do that. So I'll ask you to add loopback 3 and loopback 4 with the different IP addresses to see the effect, to see that it works. So I'll give you 1 minute for that, and then I'll come back to give you the answer. Okay, here we are. So I hope that the exercise was not difficult. So we are going to correct, to show how it works. So what you have to do, the only thing that you can do here, uh, what you can do here is to do the same job. Okay, here. Let me show something. Okay, you should do this one, config this one from here to here. You just need to copy this, come here and paste. But you have to change here. Look back 3, and then you'll put 3.3.3. You should not care. The name is not really important, but let me change the name to put actually Nathan. Okay, and then you comes here, you add another one. Actually, this one is look back 4 with this one 4, 4 and 4, 4. And let me change the name as well by adding the name of William. Okay, this is how you add look back. So let me save and run it. As you can see, you'll see that this look back 3 and 4 will come up. Let me run it. You'll see first the effect here. Let me run it as well. Just wait a moment. As you can see here, you see how it comes up 3, 4. Okay, as you can see here, look back 3 is okay, look back 4 is okay. And if you come inside the router, you see interface look back, interface look back 3, look back 4. Okay, let me do show IP interface brief. As you can see, look back 3 is now enabled, look back 4 is now enabled with these IP addresses. This IP address 333.444. You see 333.444. So everything looks good, everything is fine. So I hope this lab has been informative for you. If you have question, if you have query, if you have something to share with me, do not hesitate to put your comment below, and we are going to discuss together. So thank you, and I would advise you guys to practice to do that because it's not difficult as well. So thank you, thank you, thank you. Take care.